Okay, I'm going to go through how to do some of the problems on the 6-3 homework for Maple TA. So the first one we're going to go over is number 3, and it deals with the 68, 95, 99.7 rule. And so the first thing we're going to do is we're going to draw the bell curve. Pretend like that's perfect. And then this line in the middle is going to be our mean, which in this case is 21. And then our standard deviation is 4.5. So we're going to draw 3 standard deviations to the right and calculate those. So I'm going to add 4.5. So 21 plus 4.5, which gives us 25.5. And then add 4.5 again, which gives us 30. And add 4.5 again, which gives us 34.5. And then we're going to do 3 standard deviations to the left. And this time we're going to subtract 4.5. So 21 minus 4.5, which gives us 16.5. And then minus 4.5 again, which gives us 12. And then minus 4.5 again, which gives us 7.5. Okay, so now with that 68, 95, 99.7 rule, that means that we're going to have 60, I'll write it up here. Actually, I'm going to do it on the bottom instead. So we're going to have 68% fall within 1 standard deviation of the mean. So that means 68% of the numbers will fall between 16.5 and 25.5. And then if we look at the second one, 95% will fall within 2 standard deviations of the mean. So 95% will fall between 12 and 30. And then the last one is going to be the 99.7 fall between 3 standard deviations of the mean. So 99.7, so most of the numbers will fall between 7.5 and 34.5. Okay, another way to look at this is that half of the numbers, so this half right here, will represent 50 or 50%. And this half will represent 50. So 50% of the numbers fall below the mean, 50% fall above the mean. So if we want to figure out what's in between each of these, so we know that within 1 standard deviation is 68. So if we cut that in half, 68 divided in half is 34. So 34% will fall between 16.5 and 21, and then 34 will fall between 21 and 25.5. So we can continue this pattern. So let's keep all this in mind as we go through and answer these questions. So the first one says the percentage of scores less than 16.5. Okay, well, if we know that all of them up to 21 is 50, all we have to do is we have to take 50 and subtract 34, because 34 is between 16.5 and 21. So that 50 minus 34 will give us from there all the way down. So from here to here. So 50 minus 34, which gives us 16%. And I believe it'll probably already have the percent there for you. And then percentage of scores greater than 12. Okay, well, 12 is right here. We want all of the scores greater than 12. Well, we know everything in this direction. Actually, let me rewind a bit and switch colors. So let's go to green. Okay, so if we look at 12, we know that 50% will be here, and we know that 34 is here. So now we just need to figure out this section. So we know so far it's 50 plus 34. And then to figure out that section, well, we know that from here to here is 95. And then from here to here is 68. So if we do 95 minus 68, we get 27. And then we've got to put half of the 27 here and half of it here. So divide that in half, and we have 13.5. So 13.5 will go here, and 13.5 will go here. So now let's add the 13.5. If you add all of those up, you should get 97.5%. Okay, the next one, let's switch to gray. Let's see if this color shows up. So percentage of scores between 21 and 25.5. So between these two. So we already know that this is going to be 34 because it's half of that 68. So 34%. And then the next one, let's switch to a pink. Let's see, pinkish purple. So the percentage of scores between 12 and 25.5. Wait, hang on. Okay, so 12 and 25.5. So we're looking at this section. So we're looking from here all the way to here. So remember, this is within 1 standard deviation of the mean, both directions, and then this section. So we've got our 34, which equals this 68. Then we also have the 13.5. So 34 plus 34, so 68 plus 13.5 will give us 81.5. So that's how you do number 3. So number 4, suppose that the scores on particular Math 108 unit exam were normally distributed with a mean of 77 and standard deviation of 10. So on this one, if we go through and draw the curve, so it's just going to be the standard bell curve, and then this middle line is always going to be the mean, which is 77. And then we want to go 3 standard deviations. So we got 87, 97, 107. And then go 3 standard deviations the other way. So 67, 57, and 47. Okay, the first question says about what percent of the scores were above 67 for this unit exam. So it wants to know what was from here all the way to here. Well, we know this portion right here is going to be 50. So let's say 50 plus, we need this little section right here. Well, and we know within 1 standard deviation is 68%. So if we cut that in half, that gives us 34 here. So 50 plus 34 will give us 84%. Then the next one, if 1,300 BYU-I students took the exam, approximately how many scored above 87? So on this one, above 87 is all of this. So we know it's going to be the whole thing, so all of 50 minus this section, which is 34. So 50 minus 34, which gives us 16%. So this is the answer if it's asking for what percent of the scores were above 87. But it wants to know that if 1,300 students took the exam, how many of them scored above 87? Well, this means 16% of them did. And of means multiply, so we're going to take 16%, so 0.16. And then we're going to multiply that by 1,300. and then you should get 208. Remember, as you're going through and watching these videos, if I'm going too fast for you, feel free to pause it at any time if you're trying to write it out too in order to catch up. Okay, the next one, what is the standard score for a unit exam score of 87? So standard score, another name for that. Hang on, sorry, my cursor's being weird. It's not showing up in the right spot. Okay, so standard score, another name for that is z-score, which if you look on page 389, it gives you the z-score formula. So we're going to take the data value that we're dealing with. So in this case, it's 87. Here, let me write the page number really quick. Let me actually do a different color again. Sorry, I forgot to switch. Okay, so we're going to do the data score, which is 87. This is page 389. So the data score 87, we're going to subtract the mean, which we know is 77. And then we're going to divide it by the standard deviation. So we have 10 on the top, 87 minus 77 is 10, divided by 10. So our answer is just 1. So the standard score is 1, or the z-score is 1. So remember, standard score and z-score mean the same thing. Okay, the next one, number 5. So use the standard scores and percentile table. So we want to look at page 390. And this is not something that you'll need to memorize for an exam. It'll be provided for you. So page 390. So both of these, so it says the data value, which is 2.3 standard deviations above the mean. So on this one, we want to go through and find the z-score and the percentile just by looking at this table. So the z-score is going to actually be the same as the standard deviation here. So the z-score is going to be 2.3. And if we look at the table, if you go in the z-score column, and really this would be one really long column if we could fit all the numbers, but since we can't, we have to break it up into 4 columns. But all of these, they compare the z-score next to the percentile. So you'll find a negative 2.3, but you want to go where you find the positive 2.3, and you'll end up with 98.93 next to it. So that's the percentile that goes with that z-score. Okay, number 6. So on this one, same thing, we're going to use that same z-score, or that same z-table, and we want to find which z-score deals with the 80th percentile. So now, instead of looking in the z-score column, you'll want to look in the percentile column. So look in that percentile column until you find 80, and you won't find exactly 80, but you want to get as close to it as possible. So it'll be 80.23, which goes with the z-score 0.85. And I'm about out of time, so I'm going to stop this recording and then do the next 2 on another recording. So if you want to see number 7 and number 8, watch the second recording for 6C.